Okay, guys, I'm looking at some of these tests, and some people are having some rough time with some questions. So I went through and pulled all the questions that were the most missed, and so I'm going to go over those questions, and if anybody else has questions beyond what I'm going to do in this video, you feel free to email me. And let me just write down the questions real quick that I'm going to go through and do. I'm going to do 7, 9, 10, 11, 12, 15, and 17. Some of these were more missed than others, but these are the questions that few more people than I would have hoped for had missed. So those are the ones I'm going to start out with. So you guys can see on my screen I just have an example question pulled up here from Math Excel. So number 7 was the first one. So everybody's numbers, of course, will be different when you do this question, but let me draw your attention here. So it says, find the area of the triangle, side lengths 14, 14, and 24. So this is not to scale or anything like that, but if two of the sides are the same, automatically we're going to have an isosceles triangle here. So I'm going to put those two sides like that, and it says the other side there's 24. When you have an isosceles triangle, remember that vertex to the opposite side at a 90-degree angle, the height there is going to actually split this into two equal pieces. So if this is 24, this example here, this would be 12 and 12, and I'm just going to use the Pythagorean theorem there real quick to find the height. So the height squared plus 12 squared would be equal to the hypotenuse of that right triangle squared. So let me just grab my calculator real quick, see if I can lay it on the screen so you guys can see it here. Okay, so I'm just going to do 14 squared minus 12 squared, whoops, and not hit extra buttons. And so this is going to be 52. We're going to take a square root, and that's not a nice number, so I'm just going to leave that be. Now, the area of the triangle is 1/2 the base times the height. The base is 24, and the height is that square root of 52. I'll just leave it like that so I'm not rounding multiple times. And then the question is going to tell you guys to go ahead and round to the nearest tenth. So we're just going to do one decimal place here. So I'm just going to type this right in. So 0.5 times 24 times my square root of 52. And for that question, I would round to 0.5. So I'd say 86.5. It's labeled for you in the problem. So that's how I would do number 7. Okay, so next one I'm going to look at is number 9. So might be helpful if I'm on the screen. So it says, what's the area of a rhombus with the perimeter of 60 and one of the diagonals being 24? Okay, I'm going to do my best possible drawing of a rhombus. Pretend all the sides are the same. That looks terrible. Okay, if my perimeter is 60 and I know each of the sides is the same, if I have that, I'm going to take 60 divided by 4 and I'm going to get 15. So each side is 15 in your rhombus. Now, if you guys remember, the rhombus, what you need to find the area is both of the diagonals. So if you're looking over here at my lovely question on Math Excel, my example, it says one of the diagonals is 24. So let me just draw, I'm going to draw in both of the diagonals. And it totally doesn't matter, we're just using this as a reference. If, let's say this diagonal is the 24, where they meet, remember, they not only bisect each other, but they meet at a 90-degree angle. So I'm going to take that 24 and I'm going to write 12 and 12. Now, the other diagonal, I don't know what the length of it is, but I do know the diagonals of a rhombus bisect each other. So I know that these two segments have to be the same. Now, any way you want to look at it here, I've got 4 different little triangles created. They're all the same, and they would all work with the Pythagorean theorem since we intersect at a right angle here. So all I would do, just do x squared plus 12 squared. That has to be equal to the hypotenuse, which would be the 15 squared. So let me just grab my calculator here real quick and see if I can get it on the screen. So I'm going to do 15 squared minus 12 squared, which is 81. So I'm going to get x squared is equal to 81. You guys hopefully know this. This is a nice number. X is going to be 9. Okay, now, back in my picture, this is 9 and 9. Okay, when I do the actual area, it's 1/2 diagonal times diagonal. So this entire thing given to us at the start of the problem is 24. this entire diagonal, 9 and 9, would be 18. And so then that's how I would plug that in, multiply that out to get my area. All right, now here's number 10. Remember, each one of these is a little different. So I don't really need to redraw the picture here because you guys can see it on the paper. But this is supposed to be a square. So all these sides are marked with an X. This is a 26, this is 90. And because these two sides are the same, it's going to force these to be 45-degree angles. So you just have a 45, 45, 90 here. If you guys remember, honestly, there's a couple ways you could do this. We could just straight up do the Pythagorean theorem, do x squared plus x squared equals 26 squared if you want to do it like that. Or you can use the 45, 45, 90. If you want to see that little formula, I'll just draw it to the side. The two sides are the same. The hypotenuse is the side times the square root of 2. It's totally up to you how you want to do this. The picture here, the 26 is in the position where I would have the side times the square root of 2. So I'm going to divide by square root of 2 here. And honestly, the question asks you to round to the nearest tenth. So if you want to go through and rationalize and do all that, you totally can. But I don't have to leave this question in radical form the way it's worded. Oh, forgive me, I need to close my email. The way it's worded, I would honestly just do 26 divided by the square root of 2. And so to the nearest tenth, I think is what it asks you to round to. That's one decimal place. I would go 18.4 on that particular example. All right, this is number 11. And as you guys can see, I got the question there to the side. I'm just going to try to, this looks bad, but pretend this looks exactly like the problem I have there. This is isosceles, this is 9, this whole thing is 19. If I cut this off, and this is supposed to be a 45, 45, 90, pretend I drew that better. This piece here and this piece here have to be, this one has to be exactly the same. And then also the height will be the same as that. So what I would do here, these have to be the same length because of the isosceles triangle. This is 9, in between here is 9. So here's how I'm going to get the x. I'm going to take 19 minus 9, which is 10. And I'm not on the screen at all, but hopefully you heard me say that. 19 minus 9 is 10. I'm going to split that evenly between those two pieces that I just called x. So this would end up being 5 and 5. So 5 plus 9 plus 5, that will add up to 19 there. Now, I know I did not do a good job drawing. It's better on the Math Excel picture. But if this is a 45, 45, 90, then the two legs there would be the same. So that's also 5. So your formula, 1/2, if you're looking at the formula sheet, it does base 1 plus base 2. So 9 plus 19. And then you multiply that by the height. That's why we needed to get that 5, because we didn't know the height. Alright, so then I just plug this into my calculator, hopefully on the screen so you guys can see it. Sorry, I'm trying to work with this small space here. So 1/2, in the parentheses I got 9 plus 19, and then I'm going to multiply that by 5. So for that question, 70. If you end up with a radical in the problem, which I don't think you will for this one, you're going to have to write it in radical form. Alright guys, here's an example for number 15, and I know that this has a graph. I just grabbed some graph paper off my desk, so I'm going to plot these points. I've got 4, 6, I've got 4, 2, and I've got -4, -4. Yikes. Okay. Now, I know this looks kind of nasty, but let me show you a quick trick to this. So I'm actually going to turn my graph around a little bit because one of the sides was a straight line. So if that happens, I want to go ahead and just use that as base. So here's my base, and if you just count the units there, you got 4. And here's what I'm going to do. If I want the height of the triangle, remember it's got to extend from a vertex to the opposite side at a 90-degree angle, or the line containing the side opposite. So I would have to do this to get a 90-degree angle. I'd have to extend the side of my base. But if I do that, this is actually just my height. So then here's what I'm going to do. I can just count this. I got 1, 2, 3, 4, 5. Whoa, I just miscounted that. Let's do it again. 1, 2, 3, 4, 5, 6, 7, 8. And those are the only two numbers I need to do my base and my height. So area of the triangle, 1/2, the base there would be the 4, the height there would be the 8. So just as an example for that one, if you multiply that out, that should be 32. And here's a little example for number 17. I bet money if you miss question number 17, you're probably thinking that we should be using a 30, 60, 90 triangle here, but there's no angle measures given to us in that diagram at all. This is just meant to be a Pythagorean theorem question, so I'm just copying the example picture there. This is just Pythagorean theorem. So the two legs, the x and the 9, and that should be equal to the hypotenuse squared. Practice with the radical there. So this is just going to be x squared plus 81. Remember, when you square something that's a product like this, the 9 gets squared, so that would become 81. And then square root of 5 squared, the square root and squared cancel each other out, so I'm going to end up with 81 times 5 there. So this is x squared plus 81. Multiply this, you get 405. I'm going to subtract 81 from both sides, and I'm going to get x squared is equal to 324, and then we're just going to take the square root to get our answer there.